Welcome back. This is 9.3 notes, inscribed angle properties. All right, so here we have a circle, and within this circle, what we have is two angles. One is an inscribed angle, one is an central angle. So let's go ahead and take a look at these. So what we have, this is angle COR, this is our central angle, and we have angle CAR. This is our inscribed angle. And COR, this is our central angle. All right, so we're going to see if we can find a relationship between the two. The measure of the inscribed angle in a circle, the inscribed angle, that would be CAR, is half the measure of the central angle. Or you could say it's half the measure of the intercepted arc. Which is here, arc A, arc CR. So what does that mean? That means that if let's say the arc measured 100 degrees, the central angle would also measure 100 degrees because it's a central angle, and then the inscribed angle will be half of that, which would measure a total of 50 degrees. Okay, so let's go down to the bottom where it says a minor arc measures. Well, the minor arc measures less than 180 degrees. A minor arc is measured, it's labeled with two capital letters. And an arc symbol. So for example, a minor arc measures less than 180. Arc CR would be labeled like that. Let's go on to the next one. We have a major arc. A major arc measures greater than 180 degrees. This one uses three capital letters. And it also uses the arc symbol. So something that measures greater than 180 degrees, not CR, but going the other way, if we go from C to A to R, right, staying on the circumference of the circle, we can say that arc CAR measures greater than 180 degrees. Okay, so here's our next example. This one here has to be with inscribed angles intercepting conjectures arc. Now it does say to use your protractor and construct this angle APB. So let's see. What you can do is you can construct this at home. This is angle APB. So there's the angle that they're referring to. It says with your protractor construct angle AQB. So angle A to Q to B. So these are two different angles. First angle we had was APB, and the next angle we have is AQB. Now this one says inscribed angles, and also the part that you would do is you would measure these using your protractor just to verify that this conjecture holds true. Inscribed angles that intercept the same arc are, in fact, congruent. And what we can do is we can take one of these. Let's say this is angle AQB, rotate it a little bit as if this were a piece of patty paper, and then see if we can fit it right on top of the other angle, and it looks like we can. So not using a protractor, but using the tracing method with patty paper works just as good, and we just verified that inscribed angles that intercept the same arc in fact are congruent. Okay, so here what we have is the next, we are at the next conjecture. Angles inscribed in a semicircle conjecture. Angles inscribed in a semicircle. So here the first part says draw in or construct diameter AB. So we'll go ahead and put a line connecting points A and B. And then it says angles inscribed in a semicircle. Now, somewhere on that point, what you want to do is anywhere on there, put that point is put another point. You can label it C as a reference. Then what we want to do is connect point A to point C and then B to point C. It says angles inscribed in a semicircle R, and we're supposed to write down a measurement. Let's see if we can figure this out without taking any measurements. But then you can also measure to figure this out. A segment AB, that one is a diameter. There's a diameter. That means that this here is a semicircle. Right? A semicircle measures 180 degrees. Let's see, we do need, it says it is labeled with, this one requires also 3 capital letters and an arc symbol. Here we don't have another capital letter, so let's go ahead and add a capital letter D. If we were going to name this arc, we could say arc A, D, B, that's one semicircle, or we can say A, C, B, that's another arc that measures 180. Now, the endpoints of angle ACB, angle ACB are at the endpoints of the diameter. That means that it is going to measure half the distance of that arc. Well, so we have that the measure of angle ACB is going to be half the measure of the intercepted arc, which is arc ADB, or half of 180. So it turns out that this is a 90-degree angle. So angles inscribed in a semicircle are right angles, or measure 90 degrees. Right, on this one, what we're going to do is we are going to construct a cyclic quadrilateral. So in order to get this done, what we need to do is place 4 random points anywhere on this circle. Just anywhere is fine. And let's label them A, B, C, D. The next part that we want to do is we do want to connect these 4. So use your straight edge, connect A to B, B to C, C to D, and then from D back to A. This quadrilateral, because it's inside of a circle and each vertex is on the circumference of the circle, is called a cyclic quadrilateral. So this, what we say is that the opposite angles of a cyclic quadrilateral are supplementary. Meaning that the measure of angle A plus the measure of angle C is 180 degrees. You can also say that the measure of angle B plus the measure of angle D is also 180 degrees, which goes with that every quadrilateral has a total of 360 degrees. And here we have parallel lines intersect arcs conjecture. Parallel lines intersect congruent arcs in our circle. What this is saying is that the measure of arc AD is equal to the measure of arc BC. Or we can say that arc AD is congruent to arc CB. All right, so also here on the picture on the right, notice that this line intersects the circle in two different places. Let's call those A, B. So what we have is we have chord AB, or we can say, if we want to name the line itself, we can say line AB. This line that intersects the circle in two places has a special name. That special name is a secant line.